Hello everyone, my name is HighTeckMan and welcome to another tutorial. Today we're going to be learning how to make an Amazon Echo Raspberry Pi. I know that sounds like a mouthful, but basically it's a very interesting project, basically where you take the Amazon Echo source code, or we're going to take the Amazon Echo source code and basically port it over to a Raspberry Pi, which if you don't know what a Raspberry Pi is basically like a $35 computer in short. It's a very handy little device, and I personally like them. They're fun little nifty projects you can do all kinds of stuff with. This is just one of the projects that I'm going to share with you guys today. One that I kind of think is interesting because I really want to get myself an Amazon Echo, but I don't want to spend like, $100 some odd on it. So I figure, well, why don't I just try it out with the Raspberry Pi? So apparently there's a source code that allows you to do that. So what I'm going to do is I'm going to assume that you have no knowledge and no experience with a Raspberry Pi. You don't know how to program for it. You don't know what the RASPBIAN JESSIE is. You don't know some of the Python scripts. I'm going to assume all of that stuff. So I'm going to start from the very beginnings on how to download RASPBIAN JESSIE all the way to the end where we're basically plugging in our USB microphones and using Amazon Echo and our little buttons and everything like that, okay? So let's get started. So the first thing we're going to want to do is we're going to want to download what is called RASPBIAN JESSIE. Now, RASPBIAN JESSIE is basically like the OS, if you will, of the Raspberry Pi. You would need either a micro SD card or a regular SD card. It doesn't matter how big it is. Usually, I don't think there's like a cap size. But you're going to need to start off by downloading RASPBIAN JESSIE. So you want to download the zip. You can see here I've already downloaded it in the past, so I've got a copy of it here ready to go. So basically what you would do is you would open it and then you would extract the image file to your desktop or wherever you can find it that's convenient. I'm just going to cancel this procedure because, well, I'll just let it finish. Anyways, that's the first thing that we're going to need to download. The second thing we're going to need to download is a program called Win32 Disk Imager. Now what this program does is this basically takes the image that we just downloaded, so i.e. the Linux kernel, and it flashes it to the SD card, basically making the SD card the hard drive of the Raspberry Pi. So I'm going to have all these links down in the description below, as best as I can anyways. And the third thing we're going to need for this project is a program called Putty. Now, basically what Putty is it allows us to SSH into the Raspberry Pi. And if this doesn't make any sense, just trust me when I say this, it'll all make sense later. All you have to do is just, again, I'll put the links in the website for the websites down below, the direct links so you can download straight the programs. And that's pretty much all we're going to need as far as downloads are concerned. So what you're going to want to do next is you're going to want to run the Win32 Disk Imager program, and you want to point the image file, in this case, to the path that we downloaded for the image. So in this case, the RASPBIAN JESSIE. So we're just going to double click on that, and then the device, you would select your SD card. Now, I've already flashed my micro SD card. It's already here in my Raspberry Pi right now, so I'm not going to bore you with those details. Basically, once you have the device in and the image, you would just select write. It's going to format the entire SD card, and then you just go with it. And after that, you're good to go. Okay, so now that we've got the base for the Pi ready to go, I want to go over the actual things we're going to need, the components for the actual project itself, because what I just described was just a base overview of what we're going to need just to get the Pi up and running. But for this project, you can use it with the Raspberry Pi A, the B+, the Pi 2, and the 0. I mean, it'll almost work with just about any Pi. As far as items we're going to need an output speaker, such as like headphone jack, or headphones or speakers, things like that. If you're going to do it like how I'm doing it with the Raspberry Pi, it's going to be outputting to your TV's HDMI, because I'm using the HDMI port on the Raspberry Pi. The next thing we're going to need is a capture device, such as a USB microphone or a USB sound card. I personally have a old headset that I don't use anymore. This little, just for Skyping, just has a little, so you can listen and have a conversation, but I don't need it anymore. I'm going to use it for this project. So you need to have something similar to that. They're pretty open source as far as the USB microphones are concerned. You can just about use any cheap $5, $10 one from your local electronics store or whatever. And the final thing we're going to need is a button. Now you're probably going to ask, why do we need a button? Well, the problem is that according to the terms and conditions of using the Alexa voice service, we are not really allowed to activate it using the voice activation, which is the only downfall of this project. You actually have to push a button and then tell the Alexa what you want as far as a command. So you can't just go, hey Alexa, or Alexa, what's the news for today, or whatever. So that's the only downfall, and we're going to be using the GPIO pins number 18 and 3 for ground, 18 is for the actual conduction. And you need to check your Raspberry Pi as far as what the schematic is for your GPIO layout. In my case, it was a little different than other people's cases, so you just have to verify it with the type of Pi you have. Just go on like element14.com and they should have some kind of schematic about it, because that's where they're all from usually. So I need to give some credit here, because I didn't make this project at all. This was actually made by someone named Sam Mackin. Forgive me if I mispronounce your name, but he's actually the guy that started this whole project, and I've got his website up here, or his little blog post on basically how he did it basically with just a small $10 chip, and then ported over all that code to the Raspberry Pi, since it was basically the same code, which was very cool and very coincidental for all the people that have Raspberry Pis. So what he did, I went on ahead and forked his repository over to my GitHub account, and so that way we're all on the same page together. And like I said, all this is going to all make sense once we start actually going into the Pi itself and doing everything there. Okay, so now that we have everything down and ready to go, let's go ahead and fire up our Raspberry Pi. Now I have got my Raspberry Pi hooked up to an actual capture card, because there's some things that you're actually going to want to do as far as like a precursor before you get everything started. You can see here that my Raspberry Pi is loading up right now. This is basically the same thing that you're going to see when you first load up your Raspberry Pi with a copy of RASPBIAN, JESSIE, and all that stuff. This is going to take a while, so just be patient. And if you think for some reason it's not starting up, just give it a second. Usually it takes a little bit of time. It can take upward of like, I don't know, I think 3 to 5 minutes or something like that the very first time, because it's loading and making all the necessary blocks. So just give it some time. If it seems like it's on for 10 minutes and nothing's happening, or you still see the scripting prompts, go ahead and just re-download the script and then reapply it to the SD card, and then try again. Now, if you see this black screen, this is actually normal, because it's still loading all the OS up. So you can see here, it just came up with my cursor. Like I said, this will take a while the very first few times that you reboot the Raspberry Pi. So now that we've got the Raspberry Pi fully loaded up, there's a few things that you should probably do as a background, just to do some cleanup or some maintenance. So the first thing I'm going to do is, since I already have my because I have a network cable hooked up already into the Raspberry Pi. I'm not going to do this via Wi-Fi. I can do it via Wi-Fi, but I'm just not going to worry about that at the moment. If you want to see how we can configure it for Wi-Fi, we'll do that later. But again, I'm assuming you don't know anything. So what you want to do is you want to select Menu, and then you want to select Preferences. Under Preferences, select Audio Device Settings. Now this is basically where you would make your configurations for your audio devices. So in this case, I have the regular, the mixer set to default. I'm going to make this my default and select the actual controls so I can assign where the audio is going to go. So in this case, I'm going to assign it to my HDMI port, which is the PCIM slot, and just put that to full sound, and then make default. And then I'm going to select my Plantronics headset, and I'm going to select its controls for just the microphone, and then say close. And you can see here I've got the full microphone. If this button, or if this little icon here is not red, you want to click on it, because basically what happens is, for some reason your microphone isn't turned on, because for some microphones they have a mute setting, or like they've got like a special little clicker that you can click for mute or up volume, whatever. It's just sometimes it's a little different, but just make sure that that's active and lit. Select OK. All right, so that takes care of all the things that we're going to be doing as far as configuration. Two more things. Let's launch the file manager, and then I want to just double click on downloads, and I just want to just leave this window open, because we're pretty much going to be done after this. So let's launch terminal, and then once we have terminal up and running, we want to find out what our IP address is for the Pi, because from this point forward, we're going to basically be working on our Windows computer or Mac computer, wherever you're going to be using. I'm going to be using a Windows computer for this example, because you really don't need to have it plugged in or scripting on the Pi itself. You can if you choose to, but in my opinion, it's just easier if you had a full browser or something else, a little faster to work with. So what we're going to do is we're going to find out what our IP address is. So we're going to select, or we're going to type in the command ifconfig, CONFIG, space minus A as in apple, hit enter, and then now you can see all of our the Ethernet ETH0, which is our onboard LAN. So basically the only thing you have to worry about is where it says here your IP address. So in my case it's 192.168.2.194. So I have to remember that my IP address is this. This is my local IP address. There's probably an easier way to do it if you know how to access your IP address through your browser or through your router, but this is just the quickest way I'm going to do it. So as far as everything on the Pi itself goes, we're done. We have everything we need. So now I'm going to shift gears and move over to my Windows PC. Okay, so now I'm at my Windows PC. So I'm going to run the Putty program that we downloaded and installed earlier, or ran. So now that we've got Putty up and running, you see here we have a host name or IP address. So this is where you want to input your Raspberry Pi's IP address. So in my case, it was 192.168.2.194. So after that, you can go ahead and give it a name. And in my case, I called it Pi. You can save the configuration because we're going to probably need to reboot it once, but it's not important. Once you have the IP address in there, just select open if you know your IP address. So what's going to happen is going to give you a warning of potential security breach. There's no security breaches because we're logging in as a non-SSH via client. So our login for the Raspberry Pi as default is Pi, just Pi. Hit enter. And the password is Raspberry, RASPBERRY. Enter. It's all in lowercase. So now we've SSH'd into the Raspberry Pi. So now I can do anything that I need to do on the Raspberry Pi from my computer, which is, in my opinion, is a little bit more convenient. So what I'm going to do is I'm going to start off by updating a few things. Okay, so once we've loaded into the interface, we're going to type in sudo space apt-get space update, update. And that's exactly how you want to type it out. Basically what's happening is right now we are updating all of the RASPBIAN main packages and things like that, so that way we are completely up to date with the latest versions for our Raspberry Pi. This is going to take a little bit of time, so just go ahead and give it a little bit of time and we're going to come right back to it. Alright, so once everything is fully done and installed, it's going to say done, and then we're going to be able to start scripting again. Okay, so what we're going to do next is we're going to type in sudo space apt-get space install space git, Git, and then you hit enter. Now what this is doing right now is it's installing the repository so that way we can install things from GitHub. Now what GitHub is basically is a way so we can install and move scripts around and just basically programs for Linux and things like that. So what I'm going to do now is, since we've installed everything, we're going to change the directory. So we're going to hit CD to downloads, which is somewhere I'm more familiar with. So now I've changed everything to downloads. Okay, so the next code that we're going to want to run is we're going to actually going to go and retrieve the actual source code for the AlexaPi project. So what I did is I copied it over to my GitHub account, and again, all the commands and codes are going to be in the description down below, but this is the command that we want to run. Now before I hit go, I want you to notice something. I'm going to bring up the Raspberry Pi, and you're going to see here I have the downloads folder open. So as soon as I hit enter, you're going to see that it's now going to create a folder called AlexaPi. That's basically where all the repository and source code is going to that folder. So now you can see here I downloaded everything. It's all done. We're good to go. That takes care of it for this point right now as far as getting the codes now onto the Raspberry Pi. Now what we have to do is we have to create a Amazon developer account. And how you do that is we need to go to developer.amazon.com. And once we're on that website, if you don't already have an account, you can use your Amazon account and sign up for a developer console. I mean, it's a very simple process. You just basically next and you're done. So what I'm going to do is I'm going to go ahead and go into my console. Okay, so once you've gone on ahead and signed in your Amazon developer account, we're going to go ahead and select the Alexa tab up here. And then we're going to select the Alexa voice service. We're just going to get started. And I'm going to go ahead and register a new product type. We're going to call this a device because that's what this is. And we need to give this device type an ID. So in this case, what I'm going to do is I'm just going to call it Raspberry Echo. One word. Okay. I'm going to copy that. Now, we're going to also need to give it a display name. So basically this is what other devices will be able to see it on Amazon. So I'm going to call it the exact same thing, only I'm going to put a space in between Raspberry and Echo. So if you're following along, you can go ahead and do the same thing. It just makes it easier when you code it later. So let's go ahead and hit next. And what we're going to do is we're going to select a privacy security profile. We're going to create a new profile, and we're going to give it a name. So in this case, we're just going to call it Raspberry Echo, and the description, we're going to call it the same thing, basically. Only these are going to have spaces in the middle as well. So that way we got that going. And then we're going to hit next. And now it's basically generated our security profile ID in this case. So it's created, this is going to be the code that we're going to need to input into the program. So that way it'll interface with the Amazon Cloud service. So that way we can use the Alexa program. But we're not done yet. So we're going to go ahead and hit on web settings. Okay, so now that we're under web settings, we're going to go ahead and select this edit button. And then we're going to hit add another. Now what we're going to do here is under the allowed origins, we're going to need to put in http://localhost:5000, and then we're going to have to add another, and then we're going to type in the IP address of the Raspberry Pi. Now basically what this does is it confirms with Amazon, the Amazon side. Basically it allows it's going to be expecting a response from this particular IP address. So basically this is like the in and out for the conduit for the commands for Amazon Echo. So let's go ahead and type in the IP address. Okay, so we're going to type in our IP address 192.168.2.194, or whatever your IP address is, :5000. This :5000 port is very important. We're going to need this. So we're going to do the exact same thing with the other allowed return URL. So we're just going to copy and paste and copy and paste. Only at the end of this, we need to put a or a slash, and then we need to add code to the end of it. So let's go ahead and do that for both of these. So once we have our settings set up just like this, we will want to go ahead and hit next. As far as the category goes, we just say other. Description, we can just say that this is a Raspberry Pi. It's not a big deal what you put here. This is basically stuff. So I'm going to put Pi. Expectation longer than 4 months. Devices that we're planning to use for this, just put 1, and then we're going to hit next. This is, like I said, this is very basic. Apply access for Amazon Music. You can apply your Amazon Music access. I'm not going to do it right now. That's something that you can do later down the line if you like, though. So we're going to go ahead and submit, and we're good to go. So what I'm going to do is I'm going to select my Raspberry Echo that I just created. All right, so now you can see here I've got my security profile ID, the client ID, and the client secret. So basically this is like all the confirmations. Now this is why I wanted to have the Putty up and running, because you need to copy and paste all of these numbers and web URLs and all that into the Pi. So if you're actually on the Pi typing this all out, which is perfectly fine, you'll have to do this part, but this just makes it easier. So right now we're going to go back to the Putty program, and we're going to change the directory to AlexaPi. And now that we're under AlexaPi, we're going to type in sudo, sudo, space, period, comma, setup.sh. And then what this is going to do is this is going to go ahead and start installing the setup application for the Raspberry Pi, so that way we can interface with the Amazon Echo servers and everything. So basically give this a minute. It's going to take a few seconds for it to configure everything, but once it does, it's going to start asking us these questions that we're going to need to fill in. So I'll be right back. Okay, so now you can see that it's asking for our product ID. So in this case, we're going to type in Raspberry Echo, because that's what we called this thing. And then we're going to enter our security profile description. In this case, we're going to call it the exact same thing, Raspberry Echo, because we just called it that. So I'm just going to go ahead and just copy. And if you want to paste in Putty, you just right click and then it pastes automatically. This is a little trick there. So we're going to go ahead and copy and paste our security profile ID and then our client ID. Now you see why I said that it would be easier to use Putty for this, because like I said, otherwise you'd have to type this in exactly as you see it, which can be probably a pretty big headache for some people. And if you mess up, then it'll just basically be very bad. So now it's basically starting once it's finished, it's going to start the web engine. Once it's started, you'll need to point your browser to the Pi's IP address :5000. So in this case, we're going to go ahead and type in my Pi's IP address, and it's going to say hello. So I'm going to go ahead and hit OK, basically stating that, you know, I got the Pi, and you'll see this little refresh token for the Pi basically. So basically it means that it's ready to go. This is the key that it uses to refresh and basically allows you to talk to the Amazon Echo services. So now you can see everything started. We're all good to go. So at this point, you can either restart the Pi or you can you know, restart the service and test it out. But in this case, what I'm going to do is I'm going to just hit Control-C to break the procedure. And we're just going to test it out right now to see if there's any bugs or problems with it. So I'm going to activate it on my computer. I know how weird this sounds. I'm going to activate it on my computer here, but I'm going to listen for it on the Pi through my capture card. So just bear with me for a second. So I'm going to go ahead and put on my headset here so that in case that doesn't go through correctly. So in order to get it to start up the process or the its main program, you want to type in Python, Python, space main.py. Oh, it helps if I spell Python correctly.
Hello.
There we go. Now it's up and running. So once you hear it say hello, you're good to go. So what we need to do now is basically test it by pushing the quote button and then giving it a command. So what I'm going to do now is I'm going to actually move to a different camera and show you how you can actually push the button without actually having a button, because I don't actually have a button, unfortunately, but you can basically attach a breadboard and then just hook up a button manually. So I'm going to just move to that real quickly right now. Okay, so what you're going to want to do basically at this point is I'm going to jump these two pins right here. I'm going to jump this pin right here and this pin right here, and then once I jump those two together, it's going to basically simulate the button press. So I'm going to simulate the button press and then tell it what time is it in Zurich. Okay, so give me a second. What time is it in Zurich?
The time in Zurich is 1:49 a.m. on Sunday.
There we go. And that's how we have the Raspberry Pi signing up for the Amazon Echo service. So basically we made ourselves an Amazon Echo Pi. Isn't that cool? That is really cool. So now basically all we need to do is actually get a real button and hook it up. But that's basically all that's going to happen for today. So I know that was a very big and crazy project. I know we're going to make this project just with a big bang, but that's basically how we take a Raspberry Pi from absolutely no coding background at all whatsoever and make a Raspberry Pi, or a Amazon Echo Pi in this case. So thank you very much everyone for watching. If you liked that video, don't forget to comment, rate, and subscribe, and share the video with your friends. And as always, I will see you in the next tutorial.